How's that sound? Test? A little higher. There.
All right, fantastic. Nate is going to be talking through Peoplesoft automation. And take it away, Nate. Thank you.
Hi, Nate Werner. I work in the PSSA team, which is the Peoplesoft System Administration, basically supporting the whole finance, student, HR, and what we call Interaction Hub, but really what everybody knows it as MyU. All runs on a Peoplesoft infrastructure ecosystem, we'll call it. So I'm going to kind of go over how we had some challenges dealing with automation, or I should say not having the automation to deal with our deployments of application, and then see how we actually did finally get it automated and some of our hurdles. And then at the end, I'm going to do a little mini deep dive into how we solve things with Ansible. So some of you guys have worked with it or haven't worked it, give you some ideas of neat stuff you can do with it. So first of all, a little background. So Peoplesoft pretty much runs on all Oracle products, and so it's proprietary software, which includes the WebLogic, Coherence, and Tuxedo. And so basically WebLogic's our front end, the Tuxedo is like the core application server itself. And then we have Coherence, which is a cache server, which allows our session replication between our web servers. We have 13 environments to actually maintain, so we have a lot of different purposes. Each business has specialty roles for each of these, performance testing, a lot of different purposes. Some are small, some are large, and a lot of them are configured in very different ways and stuff. And we also have the core applications I talked about. The challenging part is we do almost annually upgrades, these major upgrades where we try to get it to the latest release of Peoplesoft, as well as now we're starting to do more quarterly, as we talked about security before. Security is a big thing now, and so there's been a lot of big security issues in the application. So it's forced us to do quarterly updates just about every quarter, to say. Some of these aren't as severe, but every single one so far isn't severe as we've been dealing with that. All the schedulers, when we add up all these instances where we have a web server piece, app server piece, and they all have to connect together, it totals about 600 of these instances that we deploy. So there's an incredible number of maintenance and work to do to get those out there. And it's on about 110 VMs. Kind of give or take, it grows and shrinks over time. And so it's insane. So back in ESUP, we remember ESUP Enterprise System Upgrade Project. We didn't have much automation at all. Matter of fact, a lot of it was done very manual. We had some crude bash scripts to try to keep things semi-automated, but we literally had 2 contractors in-house to help us get all the configuration deployment over weeks and weeks of deployments for all these environments. It was a very long, tedious process, very repetitive, and it's like we're begging for something to get automated. So shortly after the ESUP project, we finally started getting the move. But here's a sample diagram of our production instance, just kind of see how big it is, how many different pieces involved, lots of servers, lots of schedulers, and these different pieces of the puzzle to make Peoplesoft work for these applications. So our solution came up to be Ansible. So when we did some research, we found PeopleTools just started using Puppet for some of their things, and of course OIT was pushing out Chef, and it's like, okay, what do we want to use? So it was kind of a crazy timing, but a lot of the research, I found Ansible kind of be the best solution. Partly due to one of our biggest challenges is we were dealing with proprietary software. There are no modules or no built-in products for any of these software to really allow us to easily work with WebLogic, Tuxedo, or any of this stuff. So it kind of had to be built by scratch. We had a lot of scripts already, so we needed something just quick and easy. We can kind of mold in to task by scripting it. And then as we got better at Ansible, we could start converting those into specific steps and tasks in Ansible instead of calling scripts. So it worked out very well for us. And it was also something easy to learn as well for the team. So once we got that first pass, we were incredibly saving a lot of time on our deployments. But one of the challenges we had is we needed to standardize everything, because once you started going to infrastructure as code, everything had to be standardized in a way. So we did a lot of it in the past already, but we really had to kind of take it to the next step and do elaborate port matrices. As I kind of mentioned before, we have 600 domains, and we don't put one instance or domain. We call them a domain, but it's kind of a crude stealing of another term for domain, but it is just a single instance of an environment. And so what we had to do was create these port matrices that allowed us to apply multiple instances on the same host, which means the port had to be unique for every single instance, and our names had to be unique for every instance we deployed. So a lot of the strategy of standardizing how everything named, stored, and moved had to be all defined. Once we had all that in place, we could then start writing our infrastructure as a code using Ansible. The other problem we needed to do is how do we keep track of all these instances? Where do we store this information? How do we capture and get it? Fortunately, we were already doing some of that in the past, and so when it came to Ansible, we started using a master control file. Basically, the idea behind that is somewhere where we could control who is actually out there for an instance and where are they located. This ultimately was driven by a script that we use, a crawler basically, that basically crawled all our servers and discovered what instances are on them running and available. And they would generate this file, basically a primitive space delimited file. Matter of fact, this is changing to JSON, so it's a little more formatted to however you try to implement it. But basically, this allowed us to abstract where the domain was, because now we could actually identify the domain by a key ID, and it would tell us where that location, what server was running on. This meant that when we wrote our scripts to say I needed to start the FS production environment, I could care less what server it was running on. It would go discover where it was running and start that up. So it was kind of an idea of we could run a script anywhere to run any application wherever it was running. We hide the host level of it. So our first phase was completed by ability to really automate everything. And we really did achieve that. No manual tasks were being done to deploy a single instance of Peoplesoft, whether it was a web server, an app server, or a scheduler. And basically, that was kind of a big milestone that we did probably early last year and got past that point. All the rules were programmed as lookup files, so we use a lot of lookup concepts so that if we knew this environment had to have a certain setting, we'd use lookup tables to drive at it. I didn't want anything to be manual control. It had to be all fully automatic in that concept. And we did do wrapper scripts too, so anybody in the team could implement this, so we didn't have to have the Ansible in front of their, and then also validate the input values, so that Ansible didn't have to take care of some of those conditions. And then we also didn't have a lot of parallel operation. We had a lot of hosts, so in production we may have 20 virtual machines to apply to, but unfortunately Ansible was having troubles with parallelization way back when, so it was still doing a single host at a time. Only recently, some of the newer versions of Ansible, I think 2.1, gave us this more truly functional parallelization that we could deploy all at once in all the domains in a very fast fashion. So phase 2, which is what we're in right now, as I mentioned, completed the concept of parallel deployments. And now we added online patching or patching concept. So we could actually, if an instance is on a certain version, we could patch it to a new version and get it up to a new deployment, all using Ansible. Since all the rules were all pre-configured, it was fully automatic at that concept. Now we're working on integrating our load balancer so that in the concept, if we wanted to add a new WebLogic server, it would automatically tie it to load balancer and say, hey, add this to the pool too as well. It's a new instance of that. So we're working on some of those concepts. What we're trying to do is really get that full infrastructure automated so that all the pieces of an infrastructure can be updated as changes were occurring. And so that's our big milestone, getting that completed. And then we're looking for a new front end, and that front end right now we're looking at is the run deck. I don't know if anybody's used that. And so that's a new solution we're looking at. Once the architecture is fully automated, we have the whole architecture, we can now start providing some of these services to our app dev team. So that's kind of the whole DevOps idea where we're trying to say, here you go, app dev, you can cycle your environments whenever you want, just run process through Rundeck, and they'll take care of all the nitty-gritty work behind the scenes. Like I mentioned, completely abstracting where the application's even running on what host. So we do a lot of work to try to abstract a lot of that process. For our own team as well, we're using Rundeck to replace crontab. This is a better way to kind of manage and audit our processes. Do that. And then ultimately our main goal is to get to dynamic scaling, where we can, based off certain metric triggers, we can add a new web server, and that web server is automatically joined into the whole pool, and we'll have update scripts that will be able to kind of update the other members and make sure everybody's in the whole pool together too. So we're getting very close to that state with Peoplesoft. Oops. So the next piece I wanted to quickly talk about is just some deep dives in Ansible. Anybody who's used Ansible or curious how to solve some issues. One of our biggest challenges is because we have 600 instances, we stack a lot of instances on a single VM. So it's not like one instance on one VM. So it adds a little complexity in how Ansible, which is more kind of host kind of centric, where you're operating on a list of hosts. So our solution was, we'll use dynamic inventory. And part of that was using the inventory file, the inventory file that I mentioned earlier. And that inventory file will be loaded up as the dynamic inventory, but not only that, but also create a variable that would incorporate the list of instances on that host. And so what we use in Ansible then is a loop control that allows us then to also create a loop through all those instances. So that was an interesting challenge. That way, anything that's being ran inside that include would kind of operate like a normal single host, but really we're actually iterating through each domain instance or instance on that machine. The other challenge we had was we have a ton of settings. Each application server has a configuration file of probably 60 settings, and we change them regularly. We're constantly maintaining those and improving those for tuning. And if you have 600 instances to maintain, it's an incredible amount of configuration. So I needed to come up with a way that we could centralize all our configuration in one single manner that was easier to kind of see it in a big picture. So what we did is we used a YAML file to inventory any configuration overrides from our defaults. What that meant is, in this example here, we have a configuration value and these files are INI files, so it's pretty easy for us to work with Ansible on that. But in this example, we have the recycle count. And so our default value is specified at 50,000, but we have some environments we need to run that either lower or higher. And what we were able to do was to create these certain filters that allowed us to control where that other value might be applied to. And so in this example, in production, for CS, HR, a student, HR, and finance, we only wanted that cycle to occur every 10,000 times. So this way, we could see all the possible configuration values for this field for all our environments in one place. And now you're wondering, well, how do we get this to control Ansible to apply our configuration? So what we did is with that YAML, we load that file using a template into a variable which then we loop through with Ansible's with sub-elements. So this allows us to basically loop through that overridden configuration values and then apply it using the INI file module. And so what this really does is it allows us to set all those overrides in a completely dynamic configurable fashion, but yet still be able to go back and review all our configurations in one location. So we didn't have 30 configuration files, we just had one. So it was really nice to manage that way. So it was quite a challenge in how that works. But one thing you might notice is the win case is what we're doing is we're making sure that the app environment and this other property called purpose matches the current domain it's trying to process on. That way, it would skip those configuration values. So if we were doing prod, it only would apply that last one. It wouldn't affect the other one because it's filtered for the other environments. So just a kind of proof of concept of some things that we're able to do. That really helped a lot because there's so much configuration that we have to deal with. We needed some way to centralize that better. The other challenge is we use coherent cache servers. And so we run 2 cache servers per cluster of web servers. And that means for production, we might have 6 web servers and then 2 cache servers behind that help ensure that we have session replication. And it's really nice for us because that way we can just bounce web servers anytime we want to do maintenance without affecting the user. Their session just moves around. So the challenge here is we use the TCP type of communication, using UDP as the other protocol, which means we got to maintain a well-known address list of everybody using a cluster. Well, when you're deploying a single web server, that means we also got to know who else is part of this environment and also know who's also part of who are the clusters and where do the clusters belong in the infrastructure. So it was a fairly complex challenge, but we did come up with kind of a solution that was kind of a 2-step phase. So the first phase was using the Jinja macro linkers or the templating in Ansible to allow us to actually create a dynamic YAML file which would look up the list of web servers and then merge that list with our cache servers. And so we have standard rules of where our cache servers should exist, what hosts should they belong onto. So all this is being done beforehand to determine, do a look at where should this cache server exist, where is this web server, where are all our web servers, and collaborates this into a single list and identifies the host and the appropriate port based off those standards. We knew where everything was going to be and what the ports were going to be. Once we had this raw list of the YAML, then we popped it into the actual configuration file, which was the well-known address list structure. And here's just an example of how we had to iterate through that list and add those members to the well-known address. It's just an XML file in this case, for example. Quite challenging, but that means that we have a fully dynamic construction of how we configure all our web servers and cache servers without having to do any intervention, and we can apply it to any environment. So some environments may have more or less structure on that. So the results, creating a wrapper bash script, as I mentioned, we're able to kind of control and configure any environment we want. And here's an example of how we do patching. So here we're going to patch the entire HR production. And all we need to do is tell it what's the new version of PeopleTools, which is kind of the core engine to it, and what logic version we want to apply that to. And it'll simply go to all those members that already exist, looking through that inventory file, and operate and make the changes. And so there's lots of Ansible tasks to achieve all that, but ultimately it allows us to do a single command, do all our patching. We can do it either in parallel, which means we'll have like 10 or 12 parallel servers being patched all at once, or we can do serially and restart those environments at once so there's no intervention to the users. And here's an example how we can actually create a whole new instance or environment by passing our own little mini domain list to it, and then it'll go and fire that off and create those domains. So we really tried to simplify it up front. Here's an example of our Ansible running the CS production patch on 28 instances, which would be web servers, app servers, cache servers, I mentioned that, schedulers, all these different pieces that entail an entire environment. It took about 15 minutes to run, and it runs about 3,000 tasks. And you can see a couple of changes and OKs. There's a couple of skips probably occurring in there too, but just kind of give you an idea how large our production environment is. And this just took 15 minutes for us to do the whole patching. So it's fully automated now. I love automation. I'm really impressed. Hopefully we can get further on this and truly get that dynamic scaling, because I think that's our next phase. Because 80% of the time we have idle servers sitting out there, but we just don't have the tools to turn that off and turn it back on. So we're getting close to that. The code is available out there if you're curious. I'm always open to ideas. I'm trying to keep up with the new Ansible stuff, but feel free to give me some feedback and ideas. So thank you.
Nate, before you get down, some people might have some questions. Amanda, if you wanted you're up next. If you wanted to, I know you have to swap computers. So I was letting you, in the most awkward way possible, letting you know that we could do that. You said that took 15 minutes. What would that have taken before?
I had time for about 20, 25 minutes.
Really?
Yeah.
That fast? Okay. I was hoping for an answer like that would have taken us 6 days. Now it's 15 minutes.
Yeah.
25 minutes, 15 minutes.
Oh, before, yeah, no. Well, before we had parallelization, it was running one at a time. Yeah. So it was taking about an hour maybe.
Sure.
So now it's about 15 minutes. But before it was weeks.
Weeks. See, that's the answer I wanted. Weeks. Weeks to 15 minutes. Thank you.